Hi, welcome to another video on differential equations. So today we're going to be talking about a linearly independent or linear dependent differential equations. So what does it mean to be linearly independent or linearly dependent? Well, in order to be linearly independent, that basically means that the functions that your functions are not on the same plane. That's basically what it means. And to be linearly dependent, well, it's the opposite, where the functions are on the same plane. Okay, no big deal. So in the differential equation, all the functions in the solution must be linearly independent. So how do you test to see if they're independent or dependent? Well, there's a method called the Wronskian method. And the Wronskian's method, you basically have three functions, or you can have as many functions as you want, actually. But we'll start with three. And you take these functions and you put it into a matrix. Now this matrix will consist of the function as it is. And then in this first line, you'll have the functions as they are. And under that, you'll have the derivatives of those functions. And in the third row, you'll have the second derivative of those functions. Okay, and if you solve for this matrix, and if it equals 0, this implies that they are linearly dependent. If you solve the matrix and it does not equal 0, this implies that they are linearly independent. Okay. So we'll go ahead and take a look at a problem. So if we look at this problem, it asks to determine if these equations are linearly dependent or linear independent. So you have three functions this time. You have f1, f1 of x, f2 of x, and f3 of x. And basically what this means is that those three functions should be linearly independent in this equation. So we're going to set up our matrix, and we'll have the first function as it is, the second function as it is, and the third function as it is. Okay, so if we take the derivative of 0, that will give us 0. If we take the second derivative of 0, that's 0 still. If we take the first derivative of x, you get 1. And you take the derivative of 1, you get 0. And the derivative of e to the x is e to the x. The second derivative would be e to the x. So you could either solve this matrix by using the determinant, or if you know your matrices really well, you can say that if you have this triangle of zeros here, what you could do, and this is called diagonalizing a matrix. if you have this side where there's zeros, what you can do is you could multiply diagonally. So if you multiply 0 times 1, so basically multiplying with 0 times 1 times e to the x, that's going to equal 0. So since that equal to 0, this implies that, or therefore, it's linearly dependent, like we said before. If it equals 0, it's linearly dependent. If it does not equal 0, equals anything else, then it'll be linearly independent. So what if we had this problem? Basically, we're trying to figure out if it's dependent or independent. And we have some bounds. Before, here, it was actually from negative infinity to infinity. But now we have these two functions limited by 0 to pi halves. So we're going to go ahead and apply the Wronskian's method. We're going to set up our matrix and cotangent x. Alright, so this is where our derivatives of trig functions comes into handy. So the derivative of tangent x, that would simply be secant squared x, and the derivative of cotangent x would be negative cosecant squared x. And how do you solve this? Well, we could look at a basic general way to solve it. If we have a, b, c, d, that's going to equal a times d minus b times c. So basically what you're doing is you're going to be multiplying that and that, and you'll be multiplying secant squared x and cotangent x. Alright, so let's go ahead and do that. We're going to get, that's going to equal to negative tangent x times cosecant squared x minus secant squared x times cotangent x. And if we simplify that, that's going to be negative sine x over cosine x, because that's what tangent x is. Cosecant x squared x is 1 over sine squared x. We're going to subtract that by 1 over cosine squared x times cosine x over sine x. So we basically simplified those trig functions. And if we could see here, we will get, excuse me, one secant x will cancel out with one of these secants. Those sines. And one of these cosines will cancel there. So what we'll get is negative 1 over cosine x times sine x minus 1 over cosine x sine x, which then we will get negative 2 over cosine x sine x. Okay, now how do we solve this? Well, what happens if we plug in if we plug in 0, we couldn't. If we plugged in 0 for x, we couldn't. So what do? Well, I'm looking at this cosine x sine x, and that reminds me of a trig function. It reminds me of this identity. So basically we would have to first multiply by 2 to top and bottom. And then we can, now that looks like that identity. So then we have negative 4 over sine 2x. Now I would get, let's see, what would I get? I would get that equal to negative 4 equals to negative 4 cosecant 2x, which certainly does not equal 0. So then we can say that it is linearly dependent because it does not equal 0. And that's basically how you'd determine if something was linearly independent or dependent.